Today we are going to continue chapter 3, section 3. Average atomic mass is a weighted mass. So most elements occur naturally as a mixture of isotopes. Like example of hydrogen, we have three types of hydrogen: tritium, deuterium, tritium. So these three types called isotopes. So most elements occur naturally a mixture of isotopes. Scientists want to know the average mass of a sample like hydrogen of an element isotope. We can get average atomic mass by determining the percentage of each isotopes and then giving the proper weight to each value. So we get average atomic mass by determine the percentage of each isotope. How to calculate the weight average? So what's meant by here? Average atomic mass is a weighted average of atomic mass of naturally occurring isotopes of an element. So the meaning of average atomic mass: to weight the average of atomic mass of each element occurring isotopes of an element of this element. For example, if you have 25% of the marbles which have mass 2 gram, each one have gram mass 2 gram, and we have 75% of marbles of 3 gram each. Count the number of each type of marble. Calculate the total mass of the mixture and divide it by the total number of marble. To calculate weight, or to get the average atomic mass, we should to multiply first 25% times 2 and 75 times 3 to get the total mass of 25 marble, and which is equal to 50, and to get the total mass of 75 marbles, which is equal, we should to multiply 75 times 3 to get the total mass of 75 marbles, which is equal 125. Then adding this masses given the total mass of the marbles, the total mass of all marbles equal 50 plus 125. Then dividing the total mass by 100 divided to 175 over 100 to get what? To get the average atomic mass, or the average weighted average mass. Average marble mass equal 2.75. We have another simple method to get average atomic mass, is to multiply the atomic mass of each marble by the decimal fraction representing its percentage in the mixture, then add the product. For example, if we have 25% of marble, which is equal 0.225, when I divide 25 divided 100, 25 divided 100, we will get 0.25, and 75 divided 100, 0.75. Then multiply 0.25 with 0.75 by the mass here, 0.25 times 2 and 0.75 times 2. Then sum the mass of 2 gram and plus the mass of marble of 0 is 3 gram. The mole. What's been meant by the mole? The mole is SI unit for amount of substance. So, like centimeter, like meter, like kilogram, like gram. If you want to measure the amount of substance or elements, we use a unit called mole. So, mole, which is abbreviated mole, is the amount of substance that contains as many particles of substance in it. The mole is counting unit. It's a unit, just like dozen. We don't usually buy 12 or 24 ears of corn. We order 1 dozen or 2 dozen. Chemist you want to use 1 mole of carbon, 2 mole of iron, like this. But we cannot use gram or kilogram. But scientists use a mole to measure the amount of substance. So mole is a unit to measure amount of substance. SI unit of amount for amount of substance. Avogadro's number. Number of particles in a mole has been experimentally determined in a number of ways. The best modern way is 0.36 6.022 times 10 power 23. This is called Avogadro's number. So each element or each mole contain particles. This particle or this number is 6.02 times 10 power 23, which is called Avogadro's number. For example, 1 mole of carbon would be amount of carbon in grams that has 6.02 times 10 power 23 atom of carbon in it. So if I have 1 mole of 1 mole equal, inside 1 mole there is a particle. This particle is equal 6.02 times 10 power 23. So 1 mole of carbon contains 6.02 times 10 power 23, which is called Avogadro's number. This number called Avogadro's number. And 1 mole of carbon contain 12 gram. So 12 gram of carbon contain which is equal 6.02 times 10 power 23, as 1 mole of carbon equal 12 gram. Avogadro's number, named for the 19th century Italian scientist called Amedeo Avogadro. Avogadro's number equals 6.02 times 10 power 23 is the number of particles in 1 mole. Like, for example, 1 mole of oxygen contains 6.02 times 10 power 23. Each mole contains particles. How many particles? 6.02 times 10 power 23. Molar mass. Molar mass. What's meant by a molar mass? Molar mass is the mass of 1 mole of a substance. Mass of 1 mole of a substance, which is a unit to measure molar mass equal gram per mole. How many gram per mole? Which is called molar mass. Molar mass of an element is numerically equal to the atomic mass of the element, which can be found in the periodic table. For example, molar mass of sodium will be the same as atomic mass 6.941, but expressed in gram per mole. So 1 mole of mass equal 6.0941. So the molar mass gram. So the molar mass of sodium equals 6.941 gram per mole, as 1 mole of sodium contains 6.941 gram. This is called molar mass. How many gram per mole? The mass of 1 mole of substance. The molar mass of lithium equals 6.94 gram per mole. So we have 6.94 gram per mole. This is called molar mass. Chemists use molar mass and as a conversion factor in chemical calculation. For example, the molar mass, which is atomic mass, so molar mass is atomic mass of helium, is 4 grams. So we have 4 grams of helium per mole, as 1 mole of helium contains 4 grams. To find how many grams of helium there are in 2 mole of helium, if we have 4 grams of helium of 1 mole, and we want to calculate how many gram in 2 mole, we just multiply 4 times 2. So 2 mole times 4 gram helium, which is equal 8 gram mole. Look at this equation. Molar mass equal mass in gram of chemical divided in mole. Molar mass equal mass in gram or equal gram per mole. Per how many mole? Look. Look, molar mass equal mass in gram of chemical divided mole. Moles, if you want to get a mole, if we have mass in gram and molar mass and want to get a mole, equal mass in gram of chemical divided molar mass. So if we have mole and molar mass and want to calculate mass in gram, we just multiply molar mass or mole times molar mass. That's it. Conversion with Avogadro's number. Conversion using Avogadro's number. Avogadro's number can be used to find the number of atoms of an element from the amount in mole, or to find amount of element in moles from the number of atoms. If we have the mole in, if we have amount of substance in gram of substance, and want to get how many mole, we just divide it by molar mass. So we divide gram of substance like this, divided molar mass to get how many mole. So if we want to get number of atom in this element, for example, if we have 2 mole of carbon, and want to get how many atom inside in these 2 moles, how many atom of carbon in 2 mole, we just multiply by Avogadro's number by 60.2 times 10 power 23 to get how many mole. Just multiply mole, for example 2 mole times 6.02 times 10 power 23 to get number of atom or molecules inside this mole, inside 2 mole, in 2 mole. But if we have number of atom and want to get mole, we just divide it by Avogadro's number to get how many mole. If we know the mole and molar mass and want to get the amount of substance in gram, we just multiply by molar mass, like here. If we know the mole and molar mass and want and molar, if you know the mole and the molar mass and want to calculate the gram, how many gram of substance in this in 2 mole or 1 mole, so we just multiply by molar mass. That's it. Thanks for watching.